Hey guys, we're back for our second reaction rates chemistry demo here. Today we're going to be looking at the elephant toothpaste demonstration. So, what is elephant toothpaste? You may have heard of this before. Basically, it uses hydrogen peroxide, sodium iodide, and soap. So it's pretty easy to set up. First, you pour the hydrogen peroxide into usually we use a big graduated cylinder. Then you add a little bit of soap to it. And finally, sodium iodide. Now, the one we use in this demonstration is 30%, at least for our bigger ones, and I'll tell you which ones are which. That's 10 times stronger than the peroxide you have in your medicine cabinet, which is usually like 3%. And we did use some 3% in this as well, just to show you the difference between a 30% and a 3%. You would not want to put 30% on a cut. Hydrogen peroxide, as it gets more concentrated, gets scary dangerous. I saw it, like it was a forum somewhere, and the guy was like, "Hey, can we distill hydrogen peroxide to like make it more concentrated?" And the top response was like, "Well, you could, but if you go above 70% and your glassware has any imperfections, it'll just explode in your face and remove anything that's not covered in safety goggles." So 30% is already pretty high up the charts, but you can get it higher. It's just not a good idea. Anyways, what happens is when we put sodium iodide in there, it's actually a catalyst for the decomposition of peroxide. So sodium iodide goes in and catalyzes the decomposition of this. It pulls the oxygen off. And so you end up with just water in the bottom and a ton of oxygen gas. Now, this oxygen gas gets trapped in the soap because we added soap to the hydrogen peroxide, which means you start foaming and bubbling and fizzing. So you get a bunch of oxygen gas, you get some water, and you get elemental iodine, which, as you guys should know by now, is a halogen. Not a lot of fun to play with. So you're always going to want to wear gloves while doing this. The foam has a yellow color to it, and if you touch that in any way, shape, or form, it'll stain your hand. Like, even if it's really dilute, your hand will be permanently stained. It almost stained or burned through one of the gloves I was wearing, so that was fun. Now, there is a kids-safe version of this if you want to do it at home. We're not going to do that. We're going to do the real version here. This is big boy chemistry time. So, as you can see, I got my gloves, I got my lab coat, got my glasses. Safety first. So what we did here, before I hit the play button, we have three. Actually, I'll play it a little bit. See if we can see this here. Okay. So you can see we got three graduated cylinders set up. I got my handy lab assistant, Mr. Soretta, here filming for me, and he helped me set this up as well. This one here contains 30% hydrogen peroxide, and I'm pouring in hot sodium iodide. So not only is it concentrated, but we're also playing with temperatures. So you can see the difference of temperature as well as concentration on reaction rate. The second one is 30% as well, but I'm going to use cold sodium iodide as the catalyst. And so it'll be the same catalyst, but I just put this on a hot plate till it was almost boiling for the first one, and the other one will be just sitting outside at whatever it was, 5 degrees in the second one. You'll see the difference in reaction rate. The third beaker here it's still sodium peroxide, but it's only 3%. So it's 1/10 the concentration. We'll use the cold catalyst as well, and we'll see the difference in reaction rate. So here we go. So we're pouring the hot catalyst into the 30% peroxide. You can see bubbly, 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 and off it goes. It was also really windy out this day, so that was pretty sketchy. We almost caught Mr. Soretta with some iodine gas splash bubble thing. So you can see it's making like a lot of foam. It's coming out here. So it's reacting quite quickly. You're getting quite a bit of foam out the top. Now we're going to add the cold catalyst to the 30% peroxide. Oh, and the wind blew over my hot one. So the cold one starts up. And you can see much slower. Even with it getting knocked over by the wind. Much slower. So it's still going up there, but like you're not getting nearly as much. And this is where I almost burned through my gloves with iodine foam. So it's the reaction still happening, but it's not like spewing out of the top. It's just kind of oozing out of the top. You'll get the same amount of bubbles at the end because it's the same amount of peroxide. It just takes a little longer for this to happen. Finally, the 3% with the cold catalyst. Now my hair looks awful. Hashtag quarantine haircuts. There we go. Exciting, isn't it? I see some bubbles. Let's get in there. Look at all those bubbles. There's like 12 of them. So you wait, and you can actually see it's fizzing a bit. It looks kind of like let's call it sparkling apple juice. So yeah, that full disclosure. Once we started bringing these back inside, by the time we got this back up and into the science lab, it had foamed like all the way up to here. So in another 5 minutes, that foam had slowly climbed the beaker. Like the reaction still happens. So it's still going on in there. It's just significantly slower. So that's a really good demonstration of the difference that both concentration and temperature can make to reaction rate. So you can see the hot catalyst reacted much faster, the cold catalyst a bit slower, and the difference of a factor of 10 change in concentration was huge. Like that reaction almost you could barely see it happening for that third trial there. So thanks for watching, guys. That's the last of our reaction rate chemistry demos, and so we'll be back next week with some new stuff. Catch you later.